Thank you for inviting me. Good morning, everyone. Very nice to be here. We are a producer of sustainable fuels. We heard in the morning talk about e-fuels, so that's more or less what we do. We emerged from ETH Zurich, the Swiss Federal Institute of Technology, about 10 years ago, with the mission to replace fossil fuels by sustainable synthetic fuels. So we are primarily focused on the sectors which are most difficult to defossilize: aviation, shipping, and long-distance transportation in general. Now let me see if I figure out exactly. So what we try to address is the following. We consume almost 3 billion tons of fossil fuels per year. And we believe liquid hydrocarbons are here to stay because of their specific properties, especially the high energy density, which you need for long-haul aviation, for example. So this high energy content, which is about 50 times greater than the best iron lithium batteries, is the reason why you're not flying from Oman to the US, for example, with batteries. You cannot store enough energy. So we have today about 100,000 flights every day and about 20,000 airplanes in the air at all times. So that's quite massive. So the challenge is massive. And what we aim to do is to replace fossil fuels with sustainable synthetic fuels which are produced with scalable technology to meet those large demands, and importantly, produce fuels which are compatible with the current fuel infrastructure. So compatible with current refineries, distribution networks, and also the vehicles. So fuels which can be used today with our planes, cars, and ships without modification. We have quite a large range of customers, and that drop-in capability is exactly what they really desire. So we have customers, for example, the Lufthansa Group. It's the biggest airline group in Europe, with Swiss International Airlines. We have Pilatus, a private jet manufacturer for sustainable aviation fuel. But we produce also diesel. So we have a navigation company. We have the airport of Zurich operating the buses. We have even a mountain resort operating the snow groomers with our synthetic sustainable diesel. And a car company, Amag is the biggest car importer, operating the cars or using the gasoline, sustainable gasoline for the cars. So it's really that drop-in capability, this complete ability to drop it into the vehicles without changing anything, which is really attractive for them. We have long-term offtake agreements with those players, which are actually pioneering and helping us to scale the technology. Now, we are particularly focused on sustainable aviation fuel because we have a clear regulation in Europe, including Switzerland, on the demand side. So we heard it before. We have blend-in mandates. Actually, which started this year. 2% of the jet fuel needs to be sustainable, and this grows to eventually 70% by 2050. So we have 2% today, 6% by 2030, 20% by 2035, and so on. So this gives us a very clear perspective on the future demand. We see roughly in 2050, we see around 200 million tons of sustainable jet fuel demanded, just based on the regulator. When we look at the supply side, we have today a market size of around 1 million tons, all produced from used cooking oils and animal fats. So relatively simple to produce. You just take the oil and you put it into a refinery, you refine it into the fuels. This fuel type will be expanded up to around 2030. So now, especially the oil majors are integrating the waste value chains to get to the feedstock, to scale up the production of sustainable aviation fuel. This will come to a supply limit at around 2030 because there is not more feedstock available. You have a limited amount of used cooking oil unless you build new McDonald's or Burger Kings. So there is a limited amount, which then is the reason why beyond 2030 we expect a gap opening up between the regulatory demand for sustainable aviation fuel and the supply. So this gap requires advanced scalable technology to meet the additional demand. And this is our mission. So we develop an advanced, scalable, sustainable technology to meet this demand gap beyond 2030. Now, we have today a first industrial pilot plant on the ground. It's located in Germany, 1 hour from Düsseldorf or Cologne. It's an industrial pilot plant, fully operational, which converts a local bio-waste into sustainable transportation fuels using solar energy to drive the process. So this plant was inaugurated in summer and then commissioned in about 2 weeks and 2 months, and is now fully operational. We operate it 24 hours a day for 5 days a week. So we leave out the weekends, so we build up the capabilities of operating plants. This is a schematic of the process. I'm not diving into all the details, but in essence what we are doing is we revert the combustion process. When you burn a fuel, for example kerosene, you emit water and CO2. So by taking a bio-waste as the carbon material, we capture, so to say, the carbon from the air. So while growing, the plant captures the carbon from the atmosphere. So we take a bio-waste, we turn it with an anaerobic digestion plant into raw biogas comprising biomethane and CO2. And we process it in our process at high temperatures into syngas, which is a mixture of hydrogen and carbon monoxide, which is then converted with standard technology into the liquid transportation fuels. Our core technology is in the middle, so converting raw biogas into syngas using high temperature solar heat. So we produce heat at above 1,000 degrees Celsius to drive the chemistry. So this heat provides the energy for the conversion. And we integrate also thermal energy storage in the system such that this plant operates 24 hours a day without interruption. So even when the sun is not shining. This is a cross-section of the plant showing the core components. So in the top we have an electric gas heater, so we turn green electricity into high temperature process heat beyond 1,000 degrees. We have a thermal energy storage integrated, as explained, to cover the nighttime, to operate the plant 24 hours a day. Thermochemical reactor to produce syngas, and the whole heat transfer loop to transfer the heat and drive the chemistry. This is our core technology. We have about 21 patent families in this core. The nice thing, to keep it short, what is really special about this technology, we use heat instead of electricity, so we drive the chemistry with heat. This has the advantage you can cheaply generate it and you can cheaply store it in order to provide it 24 hours a day to the process without the need of any green hydrogen. So this makes this process very competitive. Now, in terms of scale-up strategy, so we have our first pilot plant on the ground in operation. We need to go big in order to bring down production costs. That's I would say, a general law in this field. You need to build big to bring down cost. Small modular plants are, from our point of view, not viable. You need to build big. So our mission is to have a 100,000 tons plant on the ground by 2030, and this could give an impression of this plant. So we scale from our industrial scale plant Dawn, which we will, in the next step, which will expand by a factor of 10 in Germany. So we'll increase the core technology by a factor of 10 in order to reach we call it Plant Shine. It's a 100,000 tons plant per annum by 2030 to have this plant on the ground. And we are exploring now territories, and Oman would really be an ideal location for us. That's actually why I'm here. So the mission is to have this 100,000 ton plant on the ground by 2030, where we see very attractive economics. We expect fuel production costs in a range of about €2 per liter. So that would be around 1 real per liter. So quite competitive against all the other e-fuel or synthetic fuel routes. And then we start to replicate. So once this plant is on the ground, we have the technology in the market at the relevant size, and then the technology is replicated with a long-term vision of bringing the cost down to below €1 per liter. so below 0.5 real per liter, which we believe is cheap enough to be integrated then into the value chains of airlines and so on, and will not impact ticket prices or traveling costs significantly. We are now about 60 full-time employees, mainly in Switzerland and Germany, and are now expanding into other fields. And we work heavily with industrial partners along the value chain. So we have big industry players like ENI or the SMS Group or Cemex and so on, building with us the core components, building with us the plants, scaling the technology up to the end customers which are using our fuels. Thank you very much. Looking forward to questions and discussions.